welcome back to another video on the Monkey Mathematician. Today we'll be looking at representing unknown values, and this will be mainly focusing on what we like to call algebra. And so we'll start off with knowing what unknown values are. So unknown values are numbers that aren't known, or as you can think, in an expression, and letters are used for these numbers. So in the world of math or algebra uses letters to act as a substitute for numbers that you don't know. For example, we can have an equation like 4x plus 3 equals to maybe 5. In this kind of equation, we do not know what x equals to. So we use x as the value that we're looking for. So in that case, well, we'll see better examples of this later on, but that's basically how it is. So x and y are major examples, with more that will come down the line. So this can make some equations shorter. That's a good benefit of them. So for this equation, we have area of basically anything is equals to length times width. Through this, we can shorten the whole equation to a equals to L times W, with us using the first letters in each equation or each expression. We can also say it as A equals to LW. That's also a quick way of saying that. So now, we want to move on to multiplication of unknown values. So if two unknown values are multiplied, for example, using the A equals to L times W or area equals to length times width, you can put the letters together and turn it into A equals to LW, as I've said before. Something to also note is that in some equations, well, it's very rare, or in some equations you can probably see like 4C, capital letter C. My C may not be, let me try it again. My C may not be that good, but it sometimes can be 4 capital letter C plus 5 small letter c equals to 10, maybe something like that. Although it's very rare to see equations like this, it's possible. And so in this case, this capital letter C acts as a different number, and small letter c is also a different number. These are not the same numbers, and so they will not have the same value. And so here are some examples of some other equations that use these unknown values. So if we were to find the area of a triangle, normal area of a triangle formula is 1/2 times base times height. We can shorten it by taking the first letters in each number, in a sense. So we can take base, b as base, h as height. And so now it will be 1/2 times b times h, or 1/2 bh. Volume of a cube is length times length times length, or length cubed. So what we can do here is that we can go and say L times L times L, which will now equal to L cubed. The reason for this is just to make it shorter, in a sense, because a lot of times you'll be writing a lot of equations with these unknown values. So it's better for us to write it in their shorter terms than rather just having length, length, length instead of just L and L. So after that, we then have the total surface area of a cylinder. So this is a complex one, but you should know this. So the formula for the total surface area of a cylinder is 2 times pi times radius square. Then add it to 2 times pi times radius times height. You can shorten this, as we said, to their first letters. So 2 times pi times r square. Remember, the square is also affecting the radius, so you count this with the r. So 2 times pi times r square plus 2 times pi times r, and then times it by h. So then the equation will be 2 pi r square plus 2 pi r h. It just makes it easier. So with that said, we'll go on to the algebraic expressions. So these are groups of letters and numbers that are connected through operation signs. So here's a small example of a question that can come from this. So imagine the price of water being h. H is a variable, which is the same thing as unknown value, because it can continuously change with the amounts that you put in. So then there's a drink that's price is $15 more than the price of water. So then they'll ask us, what's the price of the drink in terms of each? This, especially this part is, you'll see it a lot in terms of each, in terms of rather. So the question says, there's a drink that's price is $15 more than the price of water. We know the price of water, I can say W for water equals to H. We know that is H. So we can put that aside. Then you know that there's a drink now that's price is $15 more than the price of water. If the price of rather this drink is equals to $15 more, so we can say plus, because when you say more, it basically means addition of something. So it's $15 more, so $15 plus the price of water. So again, I can say price of W. And remember what I said, these unknown values of variables can be used to substitute in the case of a value that we don't know. So remember I said price of W or water equals to H. Here we have price of W or water. So what we can do is that we can take the value that is equal to price of water, which is H, and add it here. So the price of the drink would then equal to $15 plus H. And this will make it in terms of H. Whenever they say in terms of H, in terms of X, in terms of Y, you must know that you must always have the variable that they are looking for inside the equation. So the final answer is going to be $15 plus H. So we're going to be taking a look into some rules in algebraic expressions. So algebraic expressions should always be in the simplest form, because whenever you're answering in an exam, in a test, etc., they'll always want you to keep the algebraic expression, which is the equation, in the simplest form possible, because not only does it make the work look cleaner, it reduces mistakes and it helps answers to be made quicker in a sense. So how do we put algebraic expressions into their simplest forms? Well, the first way is to know that when a number or letter is multiplied by another number or letter, they must always stick together. So in this case, we have 5 times x. So 5 times x is also known as a term, which is a coefficient, which is 5, with an unknown variable, which is x. So that's just to take notes, but 5 times x is an expression on its own. How do we make it stick together? Well, simple. If it's times especially, we must always put them together. So 5x. So 5 times x turns into 5x. Simple as that. 4 times y turns into 4y. Simple as that as well. Here's something you should also note. When a number is multiplied by a variable, which is again an unknown letter, the number comes first every time. So when we had 4 times y, you shouldn't say y4. That doesn't... Sometimes it can look like y raised to the power of 4, which is wrong, because we're doing 4 times y, not y times y times y times y. So it should be 4y. Number 2 says an unknown value that's represented by a letter can also be expressed as it being multiplied by 1. This can be seen, for example, 2 times b is equals to 2b, which is 2b is the same as b plus b. It's just like saying 1 plus 1, which equals to 2. In this case, 2b equals to b plus b. With that being said, we can also say that b equals to 1 times b, because b is just by itself. So you can say it as 1 times b. It's just like 7 equals to 7 times 1. So with that being noted, we can keep it as that. And sometimes some questions can have you asking for that or have you manipulating that to find an answer. Next, we have number 3, which is an unknown value that's divided by a number or letter. So x over 4 can be written as x divided by 4. X over y can be written as x divided by y. This is a very simple one, and you just need to know, just like 1 over 4 times x. These are the same. This is the same way to write it. It also can also be 1 over 4x or x over 4. There are different ways, but this is the best way to write. Number 4 says the square of an unknown value. How to make this in the simplest form? H times h can be the same, can be written as h squared. I want you to think of h as maybe 4. If they tell us 4 times 4, normally you also think that, okay, 4 times 4 is the same thing as 4 squared. And so if h is 4, we can also now say that h times h equals to h squared. And so that's how it is in the simplest form. H times h times h. You're multiplying h 3 times by itself. So it can be same thing as h cubed. Note, the power only applies to the number or variable directly before it. An example here is 7b squared, which can be written as 7 times b times b. If, for example, I have maybe 3b all in brackets square, this is where it gets interesting because the square is affecting both the 3 and the b. So what you can do is that you can take the 3 out. So you can say 3 square, which you can make the square affect the 3. And then you can say times b square, where you can make the 2 affect the b. So now we'll turn it to 9b square. Because 3 square is equals to 9, and then 9b square. But just to note, this is only when they are both in brackets and you can see the power affecting them. If it's maybe like 3b square and there's no brackets, but it's only b that's being affected, then it's only accountable for b. So then it will be 3 times b times b. There will be no increment in the 3. As I said, the power being outside the brackets. Here's another good example. xy cubed. All in bracket cubed though. So you know that this is the x and y are both being affected by the cubed. So just as I said before, we can say we can allow the 3 to first affect the x. So then it will be x cubed, or rather x times x times x. Also, the x may look very peculiar because I'm doing times, so let me write that better. So this is multiplication, and then these are the x's. X is also written different a lot of times in algebra. Normally it looks like this, but then in algebra, most of the time we always write it as this, so as to not complicate things. So back to the question, x cubed will be affected first, then we go to the y, which will also be affected by the cubed, and so it will become y cubed. And so both of them together will lead to x cubed, y cubed. So here's a small exercise that we can do. You can pause it now so you can be able to answer it, but I'll start answering now. The first question, or rather A, states 6 times x times y. Normally what I like to do is that whenever the question is like this, I always like to write it out first so I can manipulate it easily. So 6 times x times y. It's a very, in the world of math, this is a very simple one. And remember what I said in the first row, that when you have a multiplication, they must stick together. So 6 being the coefficient, you know this more later, but 6 being the coefficient will stick with x and will also stick with y. So 6 times x, let's first start with that in a sense. 6 times x is 6x, and then times it by y again. It will then become 6xy. They must all stick together. And this is a very simple way to do it. After that, we have 7 times a times b. Again, this is following the first row. So 7 times a times b. You can simply put this in brackets. First do 7 times a, and then that will be 7a, and then times it by b. The b will now stick. So it will now be 7ab. After that, question C, x, y, z. X times y times z. Again, same thing. X times y times z. You can first put this in the brackets, stick these two together, so it's now xy, and then times it by z. So that will become xyz. That's the first exercise. We'll look at the second one. This is a little bit of a trickier one, but you can be able to get the hang of it. Question M states 4 times x plus 5 times y. We're taking a look into a more complex area, and here we'll have 4 times x plus 5 times y. In this case, remember, first rule states whenever it's being multiplied, they must stick together. And you notice that there's a plus. So we can take the parts that are being multiplied and put a bracket between them. So 4 times x will have a bracket and 5 times y will also have a bracket. So what we can do here is that we can stick these two together, 4 times x, making it 4x, and then adding the plus, because this is a different operation to multiplication, obviously. And then we can do 5 times y, so 5y. So the final answer will be 4x plus 5y. Next question, question N, states a times 7 minus 2 times b. We can do the same thing here. A times 7 minus 2 times b. Remember, we put a bracket between the two numbers that are being multiplied. If it's more than two numbers, like maybe a times 7 times 3, we'll put a bracket between those numbers that are being multiplied. That's a better way to say it. So anyways, back to it. A times 7 will lead to 7a. Remember, the number must always come first before the unknown variable. So it will become 7a minus 2 times b becomes 2b. And so remember, the minus is acting on this bracket, so it will now become minus 2b. So n will now equal to 7a minus 2b. Let me write this better. The third will be question O. So O states 2 times x minus 4. This is a very, very interesting question. So what we can do, again, state out the question at first. Remember, my x looks like this. This is my x, this is my x. Let me erase this part so that the x can look better. So 2 times x minus 4. What we can do is that we can kind of break it down, just as I did with the questions beforehand. We can put a bracket here to first do the 2 times x. This will lead to 2x. And then we can times this by x minus 4. In some later videos, you will learn a bit better about this. But in this case, we have a bracket that's affecting both the x and minus 4. What we must do is that we must allow this 2x to affect both this x and affect the minus 4. How we can do this is that we can say 2x times x. Put that one in brackets. We can take this x out and put it here. And then say minus, because the operation here is a minus. If it was a plus, we'll have added a plus. And then minus into brackets 2x times 4. What we do here is that we took out the, what's this word? The two values or variables or numbers, x and minus 4. And we put them aside, allowing them to both be multiplied by 2x. So this will then become 2x times x, which is 2x times x again, which is then 2x squared. And then 2x times 4 becomes 8x. And remember, the minus is acting here again. So then be 2x squared minus 8x. Let me erase this to make it look better. And so that's basically how you do it for that. In later videos, we'll learn a bit better about the expansion of what's this word, of variables. But with that being said, that's the final answer for this case. So we're taking a look at exercise 3. You can pause the video now to answer it yourself, but I'll be starting now. So the question says, let the unknown number be m. And now we have to write expressions for question A, which says the sum of the unknown number and 13. Sum means addition. So what you're going to do there is that you take the unknown number, which is m, and you add it to 13. And so that will be your answer for that. The second question is a number that will exceed the unknown number by 5. So this question says exceed. It may sound a bit confusing at first, but basically what it says is a number that is higher than your unknown number. In this case, exceed means addition. So you can say m plus 5, because a number that will exceed the unknown number by 5 means that the new number that we're looking for will be 5 higher than the unknown number. So basically saying that this new number that we're looking for will become m plus 5. That will become that number. And so the next question, question C, states the difference between 25 and the unknown number. Difference in math means subtraction. So what we are going to do here is that we're going to say 25 and then minus it by m, with m being the unknown number. And then the next question, which is question D, states the unknown number cubed. So the unknown number cubed means simply m times m multiplying itself by 3, or the same thing as m cubed. And so that will be that. Question E states a third of the unknown number plus 3. A third in math means 1 over 3 of a value. So maybe a third of 9 means 1 over 3 times 9, which is 3. Or 1 over 3 times, a third of 6, 1 over 3 times 6, which is 2. So a third of the unknown number means 1 over 3 times that unknown number. So 1 over 3 times m. Or in simpler terms, m over 3. And then you add 3 to that because plus means addition. So m over 3 plus 3. So that's your answer for that. So, and then the last question, F. 4 times the unknown number, take away twice the number. So 4 times the unknown number, take away twice the unknown number. We can first start with this statement, 4 times the unknown number, which is simply 4 times the unknown number. So 4 times m, which is 4m. And then after that, you must take away twice the number. So twice of the number means take away being rather my subtraction. And then you times it by 2 of that number, because twice means 2 times a number. So minus 2m. So in this case, it's just basically saying 4m minus 2m, which equals to 2m. With that being said, I'd like to thank you guys for watching the video. Hope you're able to learn a few and a lot actually. If you like, please, if you have any more questions, please send them to the comments or send them to my email, which will be posted down in the link below. And I hope you'll be able to gain more from this channel. I hope you stay. Keep enjoying yourself and stay blessed. Talk later. Bye.